Lesson 5 Dynamic Earth, the cycling of Earth's materials. Key concept. What is the rock cycle? Before you read, what do you think? Read the 5 statements below and decide whether you agree or disagree with them. Place an A in the before column if you agree with the statement, or a D if you disagree. After you've read this lesson, reread the statements to see if you have changed your mind. Read to learn. Rocks and minerals. Rocks are everywhere. Mountains, valleys, and the sea floor are made of rocks. Parts of your home are likely made of rock. Floors, countertops, and some tabletops are made of rock. Rocks and minerals. A rock is a natural solid mixture of minerals, smaller rock fragments, organic matter, or glass. Geologists call the fragments that make up a rock grains. Most rocks are composed of minerals. Minerals are naturally occurring inorganic solids that have crystal structures and definite chemical compositions. Rocks and minerals form as a result of natural processes that occur on and below Earth's surface. Geologists classify rocks or place them into groups according to how they form. The 3 major groups of rocks are igneous, sedimentary, and metamorphic. How do igneous rocks form? Igneous rocks are the most abundant rocks on Earth. Most of them form deep below Earth's surface, but some of them form on Earth's surface. Igneous rocks might form in different places, but they all form in a similar way. Igneous rock formation. When molten rock on or below Earth's surface cools, it begins to crystallize. The process of crystallization occurs when the particles dissolved in a liquid or a melt solidify and form crystals. As molten rock cools and crystallizes, it becomes igneous rock. Where do igneous rocks form? Melted rock material is present both on and below Earth's surface. Recall that molten rock that erupts onto Earth's surface is called lava. Molten rock is called magma when it is inside Earth. Igneous rocks are classified based on whether they form on Earth's surface or below. Extrusive igneous rocks. When lava cools and crystallizes on Earth's surface, the igneous rock that forms is called extrusive rock. Lava cools quickly when it comes into contact with the cooler air or water. Rapid cooling keeps large crystals from growing. Geologists describe the texture of igneous rocks with small crystals as fine grained. Sometimes lava cools too quickly to form crystals. When this occurs, the resulting extrusive rock is called volcanic glass. Obsidian is an example of volcanic glass. It has a shiny glass like surface with no internal crystalline structure. Intrusive igneous rocks. Not all magma makes it to Earth's surface. Large amounts of magma cool and crystallize beneath Earth's surface. Igneous rock that forms as magma cools underground is called intrusive. Magma cools slowly underground. No cool air comes in contact with the magma. As a result, the process of cooling and crystallization takes much longer and large crystals form. The crystals are arranged randomly in intrusive rocks. These large crystals lock together like pieces of a jigsaw puzzle. The random arrangement and large size of the crystals are features of intrusive igneous rocks. What happens to rocks at Earth's surface? When rocks such as igneous rocks are exposed on Earth's surface, they can break down into sediment and be transported to new environments. Recall that sediment is rock material that forms where rocks are broken down into smaller pieces or dissolved in water as rocks erode. How do rocks weather into sediment? Water and air can change the physical or chemical properties of rock. This change can cause rock to break apart, to dissolve, or to form new minerals. When water travels through rock, some of the elements in the rock can dissolve and be transported to new locations. Mineral and rock fragments can also be eroded by water, glacial ice, gravity, or wind. What happens to eroded sediment? Sediment is eventually deposited or laid down. Usually, the sediment ends up in a body of water such as a lake or ocean. Locations where sediment is deposited are called depositional environments. These locations are on land, along coasts, or in oceans. They include swamps, deltas, beaches, and the ocean floor. Deposition. Environments where sediment is transported and deposited quickly are high energy environments. High energy environments include fast moving rivers, ocean shores where the large waves, and deserts with strong winds. Large grains of sediment tend to be deposited in high energy environments. Smaller grains of sediment are often transported and deposited in low energy environments. Deep lakes, swamps, and areas of slow moving air or water are low energy environments. Silt and clay are deposited in low energy environments such as swamps. Sediment deposited in water often forms layers called beds. Beds often form as layers of sediment are deposited at the bottoms of rivers, lakes, and oceans. Over time, these layers can be preserved in sedimentary rocks. How do sedimentary rocks form from layers of sediment? Lithification is the process through which sediment turn into rock. Imagine sediment deposits becoming thicker over time. Younger sediment layers bury older sediment layers. Eventually, the old and young layers of sediment can be buried by even younger sediment layers. The weight from the layers of sediment forces out fluids and decreases the space between grains during a process called compactation. Cementing rock together. Compactation is often followed by a process called cementation. Cementation is the process by which minerals dissolve in surrounding water, crystallize between grains of sediment. Mineral cement holds the grains together. Common minerals that cement sediment together include quartz, calcite, and clay. What are the different types of sedimentary rocks? Sedimentary rocks are classified based on how they form. Sedimentary rocks form when sediments, rocks, fragments, or organic materials are deposited, compacted, and then cemented together. They also form when minerals dissolved in water form crystals as the water evaporates. Some ocean organisms remove minerals from the water as they form their shells or skeletons. These hard parts can form sedimentary rock, clastic sedimentary rocks. Clastic rocks are sedimentary rocks that are made up of broken pieces of minerals and rock fragments. The broken pieces and fragments are called clats. Clats occur in a variety of sizes. Sandstone, which has a gritty texture, is a common clastic sedimentary rock. Clastic rocks are identified by clast size and shape. Some sedimentary rock is made up of rounded clasts. The large sediment pieces of these rocks were polished and rounded as they bounce along the bottom of a river channel. Breccia is a sedimentary rock that has angular fragments. Its sharp edges have not been worn away. The forces that created the angular fragments were not as strong or long lived as the forces that created polished and rounded clats. Sediment size alone cannot be used to determine the environment where a clastic rock formed. Sediment pieces deposited by a glacier can be as large as a house or as small as individual grains of sugar. The ice of a glacier can move both large and small. As how The ice of a glacier can move both large and small clasts. Geologists also study the shape of clasts to help determine where the rock formed. A fast-flowing river can move large rounded pieces of sediment. Small gritty pieces of sediment are usually deposited in calm environments such as on the seafloor or a lake bottom. Chemical sedimentary rocks. As river water flows through cracks in rock, it can dissolve minerals in the rock. Rivers eventually carry these dissolved minerals to the oceans. Dissolved minerals entering the ocean add to the saltiness of seawater. Water can become saturated with dissolved minerals. When this occurs, particles can crystallize out of water to form minerals. Chemical rocks form when minerals crystallize directly from water. Some common chemical rocks are rock salt, rock gypsum, and limestone. Chemical sedimentary rocks are often have interlocking crystalline textures similar to the textures of many igneous rocks. One difference between them is that intrusive igneous rocks are composed of a variety of minerals and appear multicolored. Chemical sedimentary rocks are composed of one dominant mineral and are uniform in color. For example, granite is made of quartz, feldspar, and mica. But rock salt is composed only of the mineral halite. Biochemical sedimentary rocks. Biochemical rock is a sedimentary rock that has formed by organisms or contains the remains of organisms. Limestone is the most common biochemical sedimentary rock. Marine organisms make their hard parts from dissolved minerals in the ocean. When these organisms die, their hard parts settle to the seafloor as sediment. This sediment is compacted and cemented to form limestone. Sometimes the remains of these organisms are preserved as fossils in the sedimentary rock. Geologists use chemical properties to identify varieties of limestone. Limestone that contains fossils is called fossiliferous limestone. Limestone is classified as a type of carbonate rock because it contains the elements of carbon and oxygen. Carbonate rocks will fizz in the presence of hydraulic acid.